8.1 Law of Sines. Now previously we've talked about using the law of sines to solve case 1 and case 2 of solving triangles. Now what I want to talk about briefly is about finding the area of a triangle. Now most of us recognize that the area of a triangle is equal to 1/2 the base times the height. So if we have a triangle, and we know the height, and we know the base, then we can find the area of this triangle by this standard formula, which if you know where that comes from, you can think of it as starting at a rectangle, we know the area is equal to length times width. If we take that rectangle and we chop off a corner and put it over to the other side, we get a parallelogram. That has a height and a base, and the area is equal to base times the height. That should be a lowercase h, got a little carried away there. Base times the height, right? Because all we did was took a rectangle and chopped off a corner and put it on the opposite side. So we really, if we chop that off, put it back, we just have a length and a width. If I take that parallelogram and I chop it in half, we now have half of a parallelogram, which has the same height and the same base, so that triangle is equal to 1/2 the base times the height. So there's how we come up with our original formula for the area of a triangle. So I can get this out of the way. And that's fine if we know the height of the triangle. What if we don't? Well, let's put some measurements here. So we have A, B, C, C, A, side B. Well, that worked out handy. Okay. Well, what can I do on this? Well, when I was deriving the law of sines, I looked at it and I said, well, angle C is equal to angle C is equal to opposite over hypotenuse. Or I should say the sine of C. So I said sine of C is equal to opposite H over the hypotenuse A. And then I solved for H and I said H is equal to A times the sine of angle C. Well, if I take that information, knowing that B here is this side here, the base, right? I can now rewrite this and say A is equal to 1/2 the base times the height. The height is A sine C. Or rewriting it again, I can say A is equal to 1/2 AB sine of C, which allows me to find the area of a triangle if I have the lengths of two sides, A and B, and the angle in between them. So if I have side, angle, side, if I have that much information, then I can find the area of the triangle without knowing the height. If you give me anything that I can work with, if you give me side, side, angle, which we dealt with in case 2, we know that we can then use that to find another angle, which allows us to work through and get ourselves into the situation where we have two sides and the angle opposite. So if we have side-side angle, I can use that to find the angle opposite the other side. I can then use the sum of interior angles to get the angle in between those two sides, and I can do this. So give me side angle side, or side-side angle, and I can find the area of a triangle. So I'm going to rewrite that equation up higher so we can work on it. My eraser decided to jump. So we can get that out of the way. I'm going to leave this up here without the h in it because I don't care about the h. And I can say that A is equal to 1/2 A times B sine of C. Just remember this A is area. That is not angle A. We're dealing so much with angle A, angle B, angle C. Realize that's not angle A, that is A standing for area. So, okay. Knowing that and knowing how we solved it, remember that we used that method and then we said for the law of sines, well that means that could be done in any direction with it. So we can actually show that the area is equal to 1/2 B times C sine of A, and the area is equal to 1/2 A times C sine of B. So we can take any two sides and the angle in between them and find the area of that triangle. So if I tell you that angle B, wait, I write an A because I was saying angle B is 51.3 degrees, that side A is 13.2 inches, and side C is 19.5 inches, and I want to find the area of this triangle. I can do that by simply plugging into one of these three formulas. We have sides A and C, and we have angle B. So we're just going to plug it in. It is equal to 1/2 times A, 13.2, times C, 19.5, times the sine of B, 51.3 degrees. So grab my calculator. So 1/2 times 13.2 puts me up to 6.6 times 19.5 puts me up to 128.7. The sine of 51.3 is about 0.78. So I multiply by that and I get the area is equal to 100.44139, etc., etc. Well, I do notice that these are to the nearest tenth, everything. So I'm going to give my area to the nearest tenth, just to be consistent. So the area is equal to 100.4. We were in inches, since it's an area, that's inches squared. So from the length of two sides and the angle in between them, I was able to find the length of the area of that triangle. That could be done with any angles, any sides, any angles. So if I chose two other sides, if I gave A and C and angle A, well, that doesn't fit into this. If I have sides A and C, I need to get angle B. So how do I do that? I could take side A and angle A, because those are what I'm given, and side C to find angle C. Once I have angle C, I could add angle A and angle C together, subtract it from point A to get angle B. Now that I have angle B and those two sides, I can plug it into the equation. So that we would use the law of sines to get another angle, and then we could use that to get the third angle, allowing us to use this equation for the area of a triangle. So now we not only have the area of a triangle is equal to 1/2 the base times the height, but we also have the area of the triangle is equal to 1/2 times the product of two sides multiplied by the sine of the angle in between them. And that finishes up section 8.1, the law of sine.